ஹலோ ஹலோ சொல்லுங்க. ஏதோ இப்போ நான் ஸ்டார்ட் பண்ண போகிறேன். ஓகே. ம் Very good morning to all. This is Nadia from Pantech e-learning. Today we are going to discuss about evaluation of 5G communication. Actually, this is one day workshop on 5G communication evaluation. Okay. In this workshop, we are going to discuss about what is the digital signal processing and its introduction, and 5G communication, concept of cognitive radio network, and radio frequency and its importance, parameters of RF, and methodologies and its conclusion. Okay, so firstly, before know about generation of networks, we must know about signals, right? So firstly we discuss about what are the type of signals are there. Like to that we discuss now, then we move to 5G. Okay, actually, digital signal processing have those types of signals. One is communication and image processing, antenna design, audio processing, and video processing, right? So before know about this, we must know what is the signal and what is the digital signal, right? So digital signal processing nowadays one of the important branch of electronic and telecommunication engineering, right? So that deal with the improvisation of reliability and the accuracy of the digital communication by employing multiple techniques. Okay, in this workshop, I am explain to the basic. Firstly, I explain to basic concept of digital signal, and laterly we move to next part. Okay, then what is signal now? Okay, now we know signal, what is the important of digital signal processing, right? So before knowing about the digital signal processing, what is the signal? Okay, we must know about it, right? So anything that carries information that can be called a signal. Okay, anything that signal carries some information, right? So it can also be defined as a physical quantity that varies with time, temperature, pressure, or with any independent variables, such as maybe speech signal or video signal, anything. Okay, the process of operation in which the characteristics of a signal, that may be amplitude, shape, phase, frequency, etc. So this type of amplitude, shape, phase, and frequency, so those are undergoes a changes known as signal processing, right? Here one important point: any unwanted signal interfacing with the main signal, that is termed as noise, right? So any unwanted signal that interfacing our main signal means that is called noise. So this noise is noise also one of the signal only, but that one is unwanted signal. Then what is the types of signal? Okay, actually signal have two types. One is the analog signal, that's also we call continuous time signal. Then next type, discrete time signal. Okay, let me discuss about what is continuous time signals. Continuous time signals are defined along a continuum of time, and thus are represented by continuous independent variable. That continuous time signals are often referred as a analog signal. So that's we already discussed, right? Then These types of signal that shown continually both in amplitude and its time. Okay, this 2 point is main important in our continuous time signal. Okay, so one is amplitude and time. This will have value at each instant of time. Since that sine and cosine functions are the best example of continuous time signal. Okay, everybody know about sine and cosine functions. So those signals are one of the best example for our continuous time signal. Okay, then let me discuss about discrete time signals. Okay, these types of discrete signals we defined as independent variable. It has a distinct values. Okay, so we know every independent variable have some distinct value, right? So that is called as discrete time signal. Okay, so it have a sequence of number. So although that speech and the video signal that have the privilege to represent it both continuous and discrete time format, but under certain circumstances they are identical. That amplitude also show discrete characteristics. For example of its performance is digital signal. Okay, then come to image processing. Here that image and video processing, this is one of the important signal processing. Okay, the computer image analysis largely contain a field of computer or machine vision, and it have medical imaging, and it make a heavy use of pattern recognition and digital geometry and signal processing. This field of computer science developed. This is developed in 1950s at academic institutions such as MIT AI Lab. It's originally as a branch of artificial intelligence and robotics only. Then this type of computers are indispensable for the analysis of large amount of data, for tasks that require a complex computation, or for the extraction of quantitative information. Okay, so on the other hand, the human visual cortex is a excellent image analysis, and it is one of the best image analysis apparatus, especially for extracting higher level information and for many applications that including medicine, security, remote sensing. Human analysis still can't be replaced by computers. So for this reason, many important image analysis tools such as edge detector and neural networks that are inspired by human visual perception model. So here the computer vision is the science and technology of machines that say, as a scientific discipline, computer vision is concerned with the theory and technology for building an artificial system that obtain information from image or multidimensional data. Right. So this information is that which enable a decisions. So since perception can be seen the extraction of information from sensory signal, and that computer vision can be seen the scientific investigation of artificial system for perception from images or multimodal data. Right. So this computer vision that can be also be described as a complement of biological vision. This biological vision, the visual perception of human and various animals are studied, resulting in the model of how the system operate in terms of physiological process. Okay. In other hand, the studied and described artificial vision system that are implemented in software and hardware also. Okay, then come to antenna design. Okay, this antenna design is one of the important factor. Okay, so in this design we are using UAVs, that's over extended range, and where there are obstructed views. So while this is not directly related to antenna tracking, it may be useful for some researchers, right? So what is the fundamentals of that antenna designs? That only now we can discuss, right? So when we when we want to speak about that antenna design, the radiation also one of the part of antenna, right? So any piece of wire will radiate energy when connected to a source of our RF transmitter. Okay. So how well it radiate the applied energy, that depend on only two factors. One is antennas resonant at the same frequency as the radio signal applied, and that the feed point of the antenna is matched to the impedance of attached transmitter energy zones. Okay, so actually that is depend on these two factors only. Then I have one doubt. Is antenna have gain or not? Okay. Okay, let me discuss about this. Or let me discuss about it. Okay. So let me focus the energy, that is to greater or lesser extent. Okay. So in this direction of design, but do this by robbing energy from other radiating directions. Okay. Your torch put more light out the sorry our torch. Okay, our torch put more light out the lens end. Okay, with nothing out the rear end. If you remove that reflector from behind the torch bulb, the light is radiated in all direction, right? Uh, but it much weaker at any distance point than the focused beam. Okay, so our antenna is do not have gain, right? Then antenna radiation is polarized or not? Yeah, antenna radiation is polarized one only, because of, that is to say, the radiated electromagnetic wave has a net polarization plane. Okay, so this is usually either linear or circular. So but the antenna radiation is polarized one only. Okay. Let me discuss about types of communication. Okay, we are now discussed about what is the image processing, video processing, and antenna design also. Now let me move to communication. If once we came to communication, mean it have two types. So one is wired communication, another one is wireless communication. Okay. Under the wired communication, we have some types. Those are twisted pair, coaxial pair, and optical fiber. Then in wireless communication, that's also called unguided communication. So it's also have some types. Those are terrestrial microwave, satellite microwave, and broadcast radio. Okay, let me discuss about what is wired communication and what is the wireless communication. What is the difference between both? Okay, let me discuss about it. Okay, wired communication already there. Okay, then why nowadays people are moved to wireless communication? Okay, we want to know the differentiation between both, means we must know about some knowledge in wired communication. Okay, then we want to know about what are the drawbacks that we faced in wired communication. Then only we know the advantage of wireless communication, right? Okay, in a wired network, data is transmitted over a physical medium, right? So there are three types of wired communication. So firstly we will discuss about twisted pair. Okay, twisted pair is nothing. It consists of a pair of copper wire that is twisted around each other. The wire are around 1 to 2 millimeter thick and they are twisted to reduce the interference from the surrounding wires. Remember that the current carrying the wire has a magnetic field around it that can interface with that of another wire when it close approximately. Okay, so invented by this twisted pair is invented by Alexander Graham Bell. This form of wire has been used since the 19th century. So and it's currently cheapest medium or nowadays available. Okay, that twisted pair are also used in telephone wires. Nowadays no telephones, but before some years we used telephones, right? So that wires are based on this twisted pair only, but they only consist of 4 wires or 2 pair. So in computer network, that is 8 wire or 4 pair are utilized. So this is also known as the Ethernet cable or RJ45 cables. So those are comes under the twisted pair. So the pair of wire are bundled together and covered by a protective shield. So this is the structure of twisted pair. Then next we move to coaxial cable. Okay. In coaxial cable, it's offering a better data rate and less signal attenuation. This type of coaxial cable consists of a central copper conductor and that is surrounded by a foil shield. Okay, this foil is covered by yet another shield that's known as a braided shield. Okay, unlike the twisted pair, that coaxial cable only have a single copper conductor. If we previously we discussed about twisted pair, it have a dual copper line, right? But here this coaxial cable only have a single copper conductor. So the conductor and the foil shield are separated by a dielectric. So this is the structure of coaxial cable. Okay. Then next we move to optical fiber. Optical fiber, this is the one of the expensive of wired medium and it's offer a highest rate of data transmission, and they are often used in long distance communication and those are never affected by any electromagnetic fields. Okay, so this is because it involved light a fiber optic cable. This is a thin, flexible and a transparent medium that's made of very fine glass or plastic fibers. It utilizes the principle of total internal reflection. Unlike twisted pairs and coaxial cables, fiber optic use light pulses that generated by a laser or an injection diode. Okay, those two only used for data transmission. So each pulse of that light represents a signal bit of data. So this is the structure of optical fiber. We can also call fiber optic also. Both are same only. Then now we discussed about the structure of wired communications, right? Okay, let me discuss about what is the wireless network. Okay, the wireless network that uses a radio wave as the sole medium for transmitting and receiving data. So there are no wires involved. That example is wireless router is in our home only. So the radio wave or electromagnetic wave which are transferred in nature and they have a longest wavelength on the electromagnetic spectrum. So they travel at the speed of light and have frequencies ranges from 3 kilohertz to 3 gigahertz. So these types of that radio wave can easily be absorbed by most materials and can bend around object as well. So however they are susceptible to nearby electromagnetic field which can cause losses in the data rate. Okay, now before discuss about its types, we must know about one term that is called the electromagnetic wave. Electromagnetic wave. So that electromagnetic wave carry the electromagnetic energy of electromagnetic field through the space. So these types of electromagnetic wave that include gamma rays, that's called Y rays, and X rays and ultraviolet rays. So these visible lights and infrared ray, microwave rays and radio waves, the electromagnetic waves that are usually in wireless communication to carry the signal. Okay, why we within the wireless communication, why we discussed about electromagnetic wave means that that wave only we used to carry our signals. Okay, then this types of electromagnetic wave that consist of both electric and magnetic field in the form of time varying sinusoidal waves. So both these fields are oscillating perpendicular to each to other, and the direction of propagation of electromagnetic wave is again perpendicular to both these fields. Okay, then that mathematically we can express this term also. I think you are studied in your electromagnetic field subjects maybe. Okay, that electromagnetic wave can be described using Maxwell's equation. That pictorial representation and electromagnetic wave is shown below. Okay, I'm not mentioned here. Okay, where the electric field is acting in y-axis, the magnetic field is acting in z-axis. Okay, so this is the Maxwell equation. Okay, now we discussed about wireless network, right? Okay, then then what is the need of wireless communication? Actually, my question is why wireless communication? Okay, when wired communication can do most of the tasks that your wireless communication can, why do we need wireless communication? The primary and important benefits of wireless communication is mobility. The term mobility is very important. One of the important benefits of wireless communication is mobility. Apart from the mobility, that wireless communication also offers flexibility and ease of use, and which make it increasingly popular day by day, right? This wireless communication like mobile telephony can made anywhere and anytime with a considerable high throughput performance. Then another important point is infrastructure. So those are the wireless communication advantages. The setup and installation of infrastructure for wired communication system is one of the expensive and time-consuming job. That infrastructure for wireless communication that can be installed easily and low cost. Okay, this is the main difference between why people move to wired communication to wireless communication. The installation cost is very less and time also we can save easily. Then in emergency situation and remote locations, okay, where the setup of wired communication is difficult, that wireless communication is viable option for it. some more advantages of wireless communication. So first one is cost and mobility, ease of installation and reliability. Those are we discussed. Then important part is disaster recovery. Okay, so this is the one more advantage. So in case of accidents due to fire, flood and other disasters, the loss of communication, that infrastructures in wireless communication system can be minimal compared to wired communication. Okay, so we discussed about all the advantages. So it also has some drawbacks. So those are, the wireless communication has a number of advantages that we discussed now. There are few disadvantages. So those are the most concerning disadvantages are interference, security and health. Those 3 points. Okay. Okay, let me discuss about its type. So first one, terrestrial microwave. Okay, the terrestrial microwave, that's also we used for satellite communication, like to infrared communication also. Okay, sorry, microwave communication and infrared communications. So let me discuss about terrestrial microwave communication. Okay, that microwave technology, that can be very secure form of communication. If that signal that need to be transmitted over a short distance, it can be enough to erect two antenna with a clear line of sight. So these types of signal can then be transmitted between the two receivers. This negate the need to connect to an outside network. So this is the terrestrial microwave. Then satellite microwave. Before that satellite microwave, how the communications are used in satellite communication. Okay, so those are, that satellite communication is a crucial form of wireless communication. That means people all over the earth can communicate with each other. So this is possible only in a video, right? So it may not be possible to send a signal to other country because, well, the curvature of the earth is in the way. So this is one reason why satellites are orbiting the earth, because they can send a signal amongst themselves and eventually to the distant country. All of this at incredibly fast speed. Okay, let satellite microwave communication. So this SMC communications. So this is most effective method of transmitting microwave globally. Like to infrared technology, microwave technology that require a clear line of sight. Right? This means if you want to send a signal over a long distance means it's sending it up to a satellite first is a good idea. The only problem is that is very dense cloudy and whether the signal to the satellite can be blocked by atmosphere. That only problem. Okay, but this is a good idea. Okay, let me discuss about FDMA. Okay, FDMA is nothing. Frequency division multiple access. So why we discussed this FDMA under the wireless communication? Because of FDMA is one of the most common analog multiple access method. right? The frequency band is commonly divided into channels of equal bandwidth so that each conversation is carried on the different frequencies, right? uh, that the frequency slots are you can show in this image. Okay, this FDMA method that guard band are used between the adjacent signals spectra to minimize crosstalk between the channels. A specific frequency band is given to one person and it will received by identifying each of the frequency of the receiving end. It's often used in the first generation of analog mobile phone. Then what is the advantage of FDMA? The systems are use low bit rate compared to average delay spread. Then it reduces the bit rate information and the use of efficient numerical codes that increases the capacity. And it's also reduce the cost and lowering the intersimple interference. And it's also equalization is not necessary in this FDMA method. Then TDMA method. Okay, TDMA is nothing, time division multiple access. So it's a complex technology. Okay, compared to FDMA, it's a little bit complex technology only because it's require accurate synchronization between the transmitter and the receiver. It's also used in digital mobile radio system. The individual mobile stations that cyclically assign your frequency for the exclusive use of your time interval. In most of the cases, the entire system bandwidth for the interval of time is not assigned to a station. However, the frequency of the system is divided into subbands. And TDMA is used for multiple access in each subbands. Okay. And that TDMA that is used for multiple access in each subband. The subbands are known as carrier frequency. This each and every subbands are called as carrier frequencies. The mobile system that use these techniques is referred as multi-carrier system. Okay, so this is an example for TDMA. Then TDMA with the FDMA. What is the relationship between the TDMA and FDMA? Now we know about TDMA, right? So this is multi-carrier TDMA system. It have the 25 MHz frequency range that hold the 124 signal chains. The bandwidth of each kilohertz, each of these frequency channel contain 8 TDMA conversation channels. Thus, the sequence of time slots and frequencies that assigned to the mobile station, that is the physical channel of TDMA system. So, in each time slot, the mobile station transmits a particular data packet. The period of time that assigned to time slot that for mobile station also determines the number of TDMA channels on the carrier frequency. In this period, the time slots are combined in TDMA frame. Okay, so this is the TDMA with the FDMA, and it also has some advantage. Those are no broadband required for the wideband system, and no narrowband filter required for this wideband system. Okay, another important method is CDMA principle. Okay, CDMA is nothing. Code division multiple access. So it's a sort of multiplexing that facilitate various signal to occupy a signal transmission channel. So it optimizes the use of available bandwidth. The technology is commonly used in ultra high frequency. That's also used in cellular telephone systems bands, and it's ranging that's band ranging between 800 MHz to 1.9 GHz. Okay, so this figure is the example for CDMA principle. Yeah, the next one is OFDM. Okay, OFDM is nothing. Its working principle is OFDM is orthogonal frequency division multiplexing, right? So, okay, let me discuss about its working principle. This OFDM is a specialized FDM. It having the constraint that the substream in which the main signal is divided. Because these are orthogonal, right? So that signals are orthogonal to each other. That orthogonal signals are that are perpendicular to each other. The main property of orthogonal signal is that they do not interface with each other. Those are perpendicular to each other. Okay. So when any signal is modulated by the center, it is sideband. It is sideband and that is spread out to either side. A receiver can successfully demodulate the data only if it receives the whole signal. In case of FDM, the guard band are interested, so that interface between the signals resulting in crosstalks. So this image represents the OFDM principle. Okay, this is the generation of signal. Here we mentioned first generation, second generation and third and fourth generation. Let me discuss about it. Okay, firstly we discuss about journey of 1G to 5G. Okay. The journey from 1G to 5G that seems too recent and time has really flown. It means that block it have attempt to provide a quick summary of the journey and how we fared. Toward the end, you can also see the revenue impact on the select few telecalls that handpicked from across the globe with the evaluation of each generation of telecom. Okay, but it was a phenomenal, but it was not enough. In starting time, it was not enough. So what happened here? We must know about it, right? Because here connectivity established the seamless mobile connectivity that introducing the mobile voice service. So the first generation introduced analog device. So what are the disadvantages in analog devices? That means our first generation devices means poor voice quality and poor battery life and large phone size, and there is no security also. Then the limited capacity, poor reliability. So those are the disadvantages of our first generation systems. Then come to the second generation. Okay, so that second generation, that is revolutionary milestone in telecommunication sectors. So what happened here means the 2G, that is first wireless digital transmission that came with the 2G in 1991. So this 2G only introduced the GSM, that is the global system for mobile communication, that enabled data transfer on top of voice, and it also have the speed 30 to 35 kilobits per second. So it was primarily developed and its transfer voice and MMS also, MMS SMS services also it's provided. Then come to third generation. Okay, the third generation, what happened in third generation mean? So actually this 3G network was introduced in 1998. Okay, so actually its starting period is 1990, and within 1998 that 3G network is introduced successfully. Okay, we saw its establishment in the early 2000s. Okay, the max speed of 3G was estimated to be around 2 MP per second. So for the stationary devices and 38 kilobits per second is mobile phones, the theoretical max speed was 21.6 only. Okay, it was based on CDMA technique. So actually now you understand, right? So what is the use of that CDMA, FDMA? Why we discuss about it? Those things are. Then come to the fourth generation. Okay, now also we use fourth generation only, right? So it will provide the improved quality of video and high speed data. Then what is the fifth generation? Now also we reached fifth generation, but we don't know about its benefits, right? So actually 5G was capsulized and released with the HSPA, that means high speed packet access. Okay, it was all about the data gain. That 3.5 GB data transmission rate went up to 14 MB per second. And this 5G is more than a generation, it is a promise to Wonderland. That 5G look at within a new experience in faster data rate and a higher connection density and a much lower latency, and among other improvement. The 5G is not upgrade to 4G, but it is a leak of its own because it provides the ability to connect thousands of devices at once, and it's giving the user to true sense of real-time experience. This means the computing and the processing can move to cloud and resulting in smaller IoT devices. We can reduce the costs of that smaller IoT devices manufacturing and maintenance and by optimizing network for the telecom operator. And it's also have lot of advantages. Then that 5G mobile technology that can user in new impressive experience such as VR, AR with faster. We can implement XR also using 5G technology. So nowadays we are using both 5G and we use both 4G and 5G. So that's it. Thank you to everyone.